Hey guys, welcome back to my algorithms challenge video. Today is day 54. We're just starting off from where we left last time. So we were doing two pointers implementation. And today as well, we're going to continue doing two pointers implementation. Um, we're just going to try to master this as much as we can. Let me share my screen. We have already solved the variant of this question, intersection of two arrays. This is another variant. So given two integer arrays, nums1 and nums2, we have to return an array of their intersection, and each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So the constraint that they added is the result must appear as many times as it shows in both arrays. So you can see from the test case 1 that since 2 and 2 appeared two times, 2 appeared two times here and here. That's why they have an output of 2 times. For test case 2, we have nums1 is equals to 495, nums2 with 94984. Output is 4 and 9 because yeah, although there's two nines here, there's only one nine, so the minimum common factor is just one nine, and 4 is, yeah, 4 here, so just 4 9. So yeah, just like always, we have to, since I've already told you guys this is a two pointers question, so we have to use pointers. We would have to first sort the arrays, and then initialize pointers and also the results list as yeah, just like the output list, vacant one. And we're going to traverse both arrays using pointers. So we're not going to use left or right pointers. It's just initializing two pointers separately and then traversing at the same time, right? So we're just going to jump into the code. So first is the sorting. So we're just going to do it by nums1 sort and nums2 dot sort. Now, we have to initialize pointers. So we'll call that I equals 0, j equals 0. And we also initialize the output, which is an empty list, empty array. And now, while we have to traverse both lists, right? So I is for nums1. So while I is less than length of nums1, so while it's traversing this list, and while j is lower than length of nums2, so while j is traversing this nums2 list, so when either one of those exhausts, then this loop will stop if the element that the pointer of nums1 is pointing at from nums1 equals to the elements that the pointer that from the nums2 is pointing at. Nums2 and j will append the output of that to the output list. So output dot append nums, because we have to output the element, right? The element that I is pointing at nums1, and now after doing so, we move the pointer. So we are going to do that by I equals I plus 1, j equals j plus 1. And also elif if nums I wait is less than nums j. So uh, when it's not, when it's less than the element that the nums sorry nums 2 1 when the element that the pointer I is pointing at is lower than the element that pointer j is pointing at, then we're just gonna add 1 to the nums I, because thing is, since we sorted the two arrays in the beginning, we know that if I is lesser than j, so the element of nums 1 is lesser than element in nums 2, that means the next bigger element we can check, right? So or else j plus 1. So this is the opposite case when the element of nums2 is smaller than nums1, then it means that we cannot find it in I array. Then we have to add 1. We have to move the j pointer from nums2. So, and we return the results outputs. And let's see if this works. Yeah, so this works. As you can see, if the element of nums1 is smaller than element of nums2, then we add we move the j pointer in the nums2, since they're both already sorted, and we have to check the next biggest element. The other way around, if nums2 is smaller than nums1. So yeah, that was it. Initializing two separate pointers for two separate arrays. Maybe next time we'll do left and right pointer a few more times, or maybe medium level question. Yeah. Thank you guys all for listening. If you guys have any comments, leave it down below. I'll see you guys some other time.